3, 2, 1.
All right. Welcome to another edition of Shabbat Lounge. This is Matt.
And Jake.
And
Alan.
and we are joined today by Pete Nagel. And Pete Nagel is a mechanical engineer, and he spent 12 years at AT&T as a trainer. He's an alternative fuel expert in green power. And he started off trying to save money, and he has some pretty interesting ideas. And he's been researching ways to power your house. And so we wanted to have him on and pick his brain a little bit and just kind of have him tell his story about how he got to where he is. And because there may be people out there listening that have a homestead or are trying to be more energy independent and be in control of their energy. And they may have some questions and definitely some things to explore and check out, and we just wanted to have him on. So, Pete, it's all yours.
Cool. Good morning. Nice to meet you guys. I guess I'll hop right in. I originally started my project of powering my home. I have a small home in a small town in Kansas. It's about a 1,600 square foot home, and my thing was I wanted to see if I could power the house off of solar, so I started researching different methods of doing that. Obviously, the most popular one is photovoltaics or solar panels, and quickly realized that the price tag associated with doing that is pretty high. So I started looking at alternate methods, and of course, some of the largest solar plants that we have around the world are solar concentration. So I wanted to see if downscaling that to a single home size was feasible. And essentially did a lot of research on what other people have done up to now as far as building steam engines from scratch or the different types of steam engines. So I started out with a 8-foot diameter fiberglass C-band dish. So if anybody has ever seen an older house with a huge dish, satellite dish out in the backyard or something, that's what I started with. I got a 2-chemical chrome kit that's actually designed for chroming car parts, but I was able to chrome the inside of the satellite dish to make it essentially a 8-foot diameter parabolic mirror.
That's awesome.
Impressive.
So the chrome kit was about $160, and it took impregnating the fiberglass with nickel dust in order to get the chrome kit to actually stick to it.
Right.
Once I got that, then it turned out really nice. So I started testing how much power I could get off of that, and there's a lot of information online that you can search for as far as how much power is actually hitting the ground in various parts of the United States. In Kansas, we're about middle of the road. Some of the best places to do it are anything that's southern in the United States, so Arizona, New Mexico, Texas, Florida. Couple things, kind of caveat, is I did not want to do photovoltaics for 2 reasons. One, the price, and 2, the efficiency. So understanding a little bit more behind it, there's approximately 17 wavelengths of light and radiation that come from the sun. And only 2 of those wavelengths are photonic light. And photons are what actually strike the solar panel and knock loose electrons, and that's what begins your current flow on a solar panel to make it work. So because it's not using that much of the power coming from the sun, that's why photovoltaics are so inefficient. They don't produce a whole lot of power compared to what's actually hitting them. So if you do the calculation, where I am in Kansas, approximately 1,000 watts of power per square meter hits the ground from the sun. That's including all the different wavelengths of light and radiation. When you do solar concentration, instead of just relying on photons, you're relying on every single bandwidth that's coming down from the sun to focalize it to a specific point to generate heat. That's solar concentration. So at those heating up and cooling every single day. I pumped about 100 psi of water into that boiler, but it was a very small pump. The water, when it flash boils, produces about 1,500 times the volume. So 1 gallon of water, when you flash boil it, produces 1,500 gallons of steam. That's one of the reasons why steam power is so efficient, is because it increases in volume so much. So I had the boiler set up with just an 8-inch water line that was pumping 100 psi of water into it. And then I would get it to temperatures between 400 and 600 degrees at the focal position of that big of a dish. I would flash boil that water. Keep in mind also that you have to, in order to make it as efficient as possible, you have to paint your boiler a flat black so it absorbs as much power as possible, because darker colors absorb more power, just like walking on asphalt versus a white striped line on the road with your bare feet. You tell the difference on temperature. So it was painted with flat black stove paint, which can handle about 1,500 degrees. That boiler would get hot enough to flash boil that water into steam, and then I would take that steam line, and I was going through a regulator so that way my engine didn't blow up. But then I was going into a 3-cylinder Isuzu aluminum block engine that they use to power. It's an internal combustion engine that Isuzu provided to Chevrolet for like the Geostorm, the Geo Metro, and so on and so forth. I was using that as a steam engine, and the only way it works is by making it a 2-cycle engine. So I pulled the cam out of the engine, and I double lobed it. So wherever there was one lobe on the cam, I put an additional lobe 180 degrees on the other side of the cam. And that makes it so the valves open twice as many times. So now I have a steam line going to the intake of the engine, which I did have to make a new intake in order to handle the pressure. And then I had my cam made so it would turn it into a 2-cycle engine. And the reason why you have to use something that's at least a 3-cylinder or more is because is in the power stroke of the engine at any given point in time. If you're using a single-cylinder engine and it's not in the power stroke of the engine, when you apply steam, it doesn't do anything. It won't start itself. The whole purpose of this process is to make it so it can all be automated, so the entire system can fire up itself first thing in the morning when the sunlight hits the dish. It can start generating steam, and it can start up the engine by itself without having to have a starter motor on it. So the less things that you can have on the system that don't require power in order to get it fired up, the better. Obviously, because you're generating power for the purposes of charging batteries or powering a home or whatever. So power is something that you want to conserve as much as possible. Everybody with me so far?
Oh yeah,
Absolutely.
Yeah, it's kind of too interesting to jump in and interrupt the
The one thing I
story.
had a question about. Did you say you used an 8-inch pipe?
No, an 8-inch pipe.
8.
Oh, because I wrote that down. I was like, oh
1/8.
my goodness, that's a big pipe. Okay.
No. Sorry. So a 1/8-inch copper line
Okay.
is what was feeding the boiler. The pump that I used is an extremely small DC pump that is low volume. It's only like 5 gallons an hour or something like that. But it's at 100 psi, and it was pressure switched. So once it reached that pressure, it would automatically shut off, and then once the pressure got below 80 psi, it would fire back up again. It was essentially, if I remember correctly, I used a all stainless steel Holley fuel pump for a diesel engine.
Okay, yeah.
So did you do most of this at a shop at your place, or did you have some of this done outsourced?
The only thing that I had somebody else do was the welding on the cam.
Awesome. So when you said you manufactured a new intake for the motor to handle the pressure, did you make an entirely new intake for the engine, or were you just replacing the carburetor with some kind of a valve system?
So the intake manifold comes off of the engine, and I had a straight pipe system go to the intake ports
Right.
for the cylinder.
Okay.
That way I can run that 100 plus psi of steam pressure to the engine without it blowing up the manifold.
Gotcha.
Okay?
Because that would be bad, right?
Yeah.
Yeah. I don't know of any stock engine that can handle 100 psi without blowing up the manifold. So you do have to make sure that you have a fairly robust piped in. A lot of people that I've seen, like on YouTube, take for single cylinder applications and stuff like that. What they do is they take the intake or the carburetor off, and they'll actually pipe thread that port that goes into the cylinder, and then they'll just put a pipe right into it. Depending on what kind of engine you use, ultimately that could probably work. But I just built a flat flange intake pipe so I could pump my pressure right into the ports of the cylinders.
Okay.
So the other thing too is you have to make sure you have enough steam to run the engine efficiently, but also you have to have a blow-off valve in order, because your boiler is going to be, for a dish that size, I was making approximately 7.6 kilowatts of power when it was running at full time. So that's enough power to more than enough run the engine at the speed that I needed to generate enough power for the house and still have steam left over. So I had to have a blow-off valve, so if it did get over the pressure that was required for the engine, maintain the RPM that the coil required to generate power at the right voltage, it had somewhere to discharge steam.
Right. So basically just kind of a pop-off valve that once it reached pressure, it would release.
Correct.
Did it have like a ball?
That was a low volume pop-off valve at 120 psi.
Mm-hmm.
And then I had one that was a high volume valve. So there was one time when I was running the system that the 120 psi valve popped, but it wasn't releasing enough pressure.
Oh, wow. Wow.
So I had to put a secondary one in that gave it more volume for discharge.
Was that like a ball valve?
Like pop off on your hot water heater.
I mean, the comparison that I would use is like a pop-off valve on a water heater.
Yeah, because when you were saying that, in my experience, I grew up in agriculture, and we had pop-off valves on water systems that operated the same way, but they would be like a stand-up pipe with a plastic ball, and when the pressure got too great, that ball would allow the water to release at that point.
It's same concept.
Yeah.
But on a steam engine for a pressure relief valve, the spring load that you're using for the pressure relief valve needs to be something that is not temperature sensitive, because if under the heat of steam power, a spring loses its elasticity quite a bit. Your rating of your spring changes. And you don't want that to happen, because then your pop-off valve is something that's specifically designed for steam pressure regulation. So it's not temperature sensitive, so it doesn't change its value when it gets heated up.
Right.
Okay. Yeah, that makes sense. And you said, so where you were talking, you said you used a 3-cylinder, has to be able to start itself, and then we kind of interrupted you.
So once the steam pressure got up to at least 80 psi, there was a pressure switch on the system that would allow the steam to be delivered to the engine to get it started up. The engine had enough friction in it that it would not start rotating until it had at least about 25 to 30 psi on it. But once it got rotating, that it would get up to RPM relatively quickly. The couple main components are the dish obviously has to be pointing at the sun, directly at the sun, all day long. So in order to do that, it has to have a servo system in order for the satellite dish to track the sun throughout the day. Some people do that with a program and software with servos that tracks the position of the sun because we know where it is all the time. And other people use a solar tracker, which is much easier. So if you go to Google and you type in solar tracker, you're going to see 1,000 different posts of people that have different electronic schematics for making a solar tracker, and they're really easy to make. Some of them are using the photodiodes that are on printers in order to detect where the sun is in the sky. You have 4 of them, north, south, east, and west, and you put it behind the sunblock. So whichever photodiode actually has more light hitting it, it knows that it needs to go that direction. So on mine, I use the solar tracker to fire relays, which then in turn, we're providing power to Little Rascal, the Little Rascal scooters.
Yeah.
The motors that run those were powerful enough to actually use as servos on my satellite dish. Because with the boiler on it and the satellite dish and all the hardware and everything on the dish, it was weighing in at about 280 pounds. So I had to have something that was powerful enough to rotate it on 2 axes, so up and down and side to side. So the way I built my circuit was at the end of the night when it had been tracking the sun all day long, as soon as no diodes had any sunlight whatsoever, there was a fail switch that brought the whole dish back to the sunrise position, and it hit 2 limit switches there, and then it would shut itself down so it was ready for the sun to come up in the morning. And then once the sun started hitting those photodiodes, then it was just using those to track sunlight throughout the day until it got to sunset, and then it would just rinse, lather, and repeat every single day by itself.
Awesome. That's a good idea.
If the whole solar tracker circuit it was like $12. I kind of had a failure at one point in time where the solar tracker stopped working, and there was a fail-safe on the circuit. So if it stared at since it was staring at the sun the entire day, it was obviously putting all of that power onto the boiler. And if for any reason the boiler got too hot, there was a temperature sensor on there that if it reached 800 degrees, it would tip the dish north 10 degrees to take it out of focus, so it was no longer dumping all of that concentrated power onto the boiler. Well, I had a failure on my electronics one time that it failed to move, and it just so happened that the boiler got too hot. It was like a 95-degree day. The boiler got too hot, and it didn't tip it 10 degrees out, and it melted my boiler down. That's 3/16L stainless steel boiler, and it melted it down like it was nothing.
A good thing we don't get a lot of 95-degree days here.
We're going to have to revisit this portion of
So it is necessary to have different safeties for your equipment in place. I had to build another boiler. I changed the focal position of the boiler so it was actually, if you look at a side cutaway of a parabolic dish, you essentially get a big convex. And then where the focal position is of that dish depends on obviously its diameter. I've changed the boiler position to not be right at the focal position. I had it a little bit closer to the dish. That way the power that was hitting it was spread over more surface area instead of a fine point, which actually helped to keep it from overheating.
In college we did, well, it wasn't So you have your senior design project and everything, and we would work with different companies and do different experiments that they needed done. Well, one of the groups that had their project was essentially the difference between the photovoltaics and the concentrated solar situation, and they were trying to measure the difference if they were to concentrate the sunlight into essentially, I think what they were doing was concentrating it into a photovoltaic cell, though. So it's a little different, but same kind of concept.
There's actually quite a few companies right now that are investing millions of dollars in concentrated photovoltaics, that specific technology, where they're taking concentrated sunlight and putting it on a photocell.
Yeah.
Because they can make a photocell that's 6 by 6 inches, and just use a huge mirror to concentrate all of that sun power onto that location, because the mirror is much cheaper than a huge photocell.
Right.
So, yeah, that's a technology that's been in the works for quite some time. But again, the issue is, regardless of what kind of photocell you make, you're still only knocking loose electrons with photons.
Right.
So you're still only using some of the wavelengths of the sun to generate your power, not all of the different wavelengths of the light and the radiation. Because the radiation, UV radiation, actually produces most of the power that's hitting us that gets through the atmosphere anyway, that's coming from the sun.
Right. So do you run your house with this now?
No.
Okay.
So I had it running for a while, and then I started traveling for work for AT&T. So I actually started with DirecTV back in 2005 and worked for DirecTV up until the point where DirecTV was purchased by AT&T. And I started having to travel more for the AT&T side, doing training down in Texas, which is where I met my wife, by the way.
Good job.
So I was traveling. I was actually down in Texas more than I was home. And while the system was designed to be automated, being away from it for that period of time, if there was any kind of a problem or anything like that, it posed issues.
Yeah.
So eventually I ended up selling the entire system, and now this house is back on the grid. But what our plan is, we are in the process right now. We just sold our house down in Texas, where I met Matt, by the way.
Yep.
Well, we're actually in the process of selling it. We just got an offer for it yesterday.
Congratulations.
We are we're back up here at my house in Kansas, and we're finishing it up from the remodeling and stuff that I was doing on it to get ready to sell it. And then we're heading out east. We're looking at the North Carolina to northeastern Georgia area to buy property and build an off-grid house. And essentially I'm going to build that entire system again, but now I have a better understanding of what works and what doesn't work. I'm going to be building a more efficient system. I won't use a car engine. I'll probably be using about a 600cc motorcycle engine, like a inline 4. Because they're much less resistance and friction to get started up. It's well over the size that I'll need to generate enough power. They'll last much longer because they're a high revving engine, and I won't need to rev it that high at all to produce power. It's much less physical mass to get moving, so it'll be more efficient in that aspect. And motorcycle engines are really easy to come by at salvage yards, so but essentially I'm going to be doing the same thing. A solar concentrator using a C-band dish, motorcycle engine, that instead of changing the cam setup in it, what I'm going to do is just use the intake and exhaust valve as a method of exhausting steam, and I'm just going to port each cylinder with an electric valve to push the steam into the cylinder, and then use the intake and exhaust valves to exhaust the steam out of the engine. So that's my plan for that so far.
Interesting.
So when you sold your first system, Did it make you some money? Was it a good deal on your part?
Well, it only cost me, I think everything all inclusive, it was like $1,100, $1,200 to put it all together. And I sold it for around $3,600.
Oh, nice. And have you heard back from the person that bought
Which
it?
in no, the guy that I sold it to, I haven't heard from him.
Okay.
Which in hindsight now, though, considering how much power it generates, I probably could have made more money off of it had I had it on the market longer, but I just wanted to get rid of it. So.
And so, do you have a plan? We all have wives, and wives usually don't like to look at things like a motor sitting outside your house. So, do you,
So this is the awesome part, is I've been explaining all these things that I want to do, and my wife's on board with most of it, so it's all good.
Okay.
She wants to help. She actually wants to help build our house wherever we're going.
Yeah.
Sweet.
Well, that's the one thing I thought is, if we did that at our place, we'd probably have to, build something around it just to kind of hide it. But I wouldn't think that would be any problems as long as you gave it plenty of ventilation and plenty of space.
No, I'm cool with having a satellite dish that generates power to run my home instead of a $20,000 solar array and then flaunt it in somebody's face and say, ha.
Yeah, that's true. It's definitely kinder on the eyes than that. Yeah, that's a good point.
And the house that we're going to be building is going to be a berm house. So the power requirements for it are going to be significantly less. The way the house is going to be built, it won't even require central heater air. So my power requirements are going to be significantly lower, so the system won't have to be as big.
Yeah, I wanted to do that back in the early '80s, and the technology just wasn't available. We didn't have the vapor barriers and all that stuff that we have today to be able to deal with the moisture and everything. And
well, now they're for berm houses now, like the probably the most common one that you can find on YouTube is called the Earth Ship.
Oh yeah.
The Earth Ship house.
Yeah, I've been to
the vapor barrier around that berm now is just Pond's liner.
Yes.
So,
yeah. So I visited.
Those are good in the ground for like 40 or 50 years.
Correct. There's a facility outside of Taos, New Mexico that's an Earthship village that I visited, and there's parts of it that are very appealing and parts of it that I don't care for.
So it's funny you should say that. So we want the design characteristics and the efficiency characteristics of an Earthship, but we don't want all the labor-intensive build of it. So we're not going to use tires for the foundation walls.
Right.
And we're going to be, we might be using some of the bottle aspects that they for filler in the walls, just because once the finished product is done, it looks awesome.
Mm-hmm.
But as far as all the labor-intensive part of building an Earthship, we're not doing that. I'm going to use standard construction techniques, probably a cinder block wall for the 3 walls that will be buried.
Right.
And we're still going to do the cooling tubes through the berm to cool the house during the summer.
Of
And
course.
everything. We're going to use the gravity feed for the cooling, for the convection cooling of the house. But as far as all the labor-intensive stuff that they do on an Earthship house, we're not doing that, because that's just that requires too much manpower and time.
Yeah. Exactly.
Yeah.
And it's ugly. I don't like the tires.
Some of them actually look really good. The ones that are on a budget, obviously, because they have so many people helping them, and not all of them are volunteers.
Right.
The ones that were on a budget, you can tell, because since they spent so much money on labor, they didn't have a whole lot, for the house.
Yeah. I just don't like the tire aspect of it for the most part.
Yeah. Yeah, I mean, it's a great concept, but labor-wise, it's ridiculous.
Yeah.
Yeah. So, far as the system that I had up and running, I was not tied to the grid. When my house was running off of that system, it was not tied to the grid at all. So it was, if it went down, then my house did not have power. So and at the beginning of the time that I was traveling down to Texas, my daughter was still living with me here. So if my house went without power, then I had my daughter at home with no power, and that was obviously not a good thing. So that was one of the reasons why when I started traveling more, I got rid of the system. So.
Yeah, that makes sense.
But knowing what I know now, it'll be easier to make a system that's more reliable till it's up and running all the time. And I also did not have battery backup. So,
Yeah. Describe the battery backup. I think that that's an important piece. I remember.
On my system that I want to build for the house that we're going to be doing, instead of having just an AC generator coil, I'm probably going to have a combination of an AC generator coil and a few alternators. The alternators will directly charge the battery pack, and then there will be a grid tie inverter that actually uses the sine wave from the AC generator to map its sine wave for providing additional power to the house. So it'll be a AC generator that I'm running off of the steam engine to produce power that comes straight to the house. There will be a battery backup for at nighttime, so we have power. And then there will be a grid tie inverter that has access throughout the day, if necessary, to use the sine wave from the AC generator in order to tie, essentially instead of tying to a sine wave from a grid, it'll be tying to a sine wave coming from my generator, and then it will be able to provide power additionally to the house throughout the day if for some reason we need it, which I doubt we ever would. And then the grid tie inverter will also be able to work at night when the AC generator is not working. There's a few models of grid tie inverters out there that don't require a sine wave to sense in order to run. I just got to find out how expensive they are.
And
because in most cases, when you have a grid tie system, if your grid supply goes down and that grid tie inverter doesn't see a sine wave, it shuts down. You have no power.
And what kind of battery do you use for something like this? Is it like a marine?
No, I'm probably going to source some recycled EV batteries from like a Nissan Leaf or a Toyota Prius or something like that, something that's lithium ion.
Yeah.
So I have the deep cycle drawdown, so I can run them almost all the way down, and I have the cycle life of recharges that are much higher than lead acid or sealed batteries.
Yeah. Makes sense. Yeah, back to the motor for just a minute.
And repurposed EV batteries are actually not that difficult to come by now that more and more manufacturers have EVs on the road every time they get into an accident. Most people won't rebuild an EV car.
Correct.
Because they're in territory that they don't fully understand. So a lot of EV batteries are just sitting around because the U.S. government still does not have a method of recycling EV batteries.
So it sounds like there might be a business opportunity for someone to figure out how to reuse those.
There's actually a few startup companies within the last few years that are targeting that, specifically because when a car gets into an accident and you have a 40 kilowatt to 200 kilowatt battery in it, the battery has nowhere near reached its lifespan, but the car is not rebuildable. So there's a huge amount of resources in that battery that can be repurposed for other stuff, and some people started realizing that. So there are some startup companies that are going to be doing that. I think there's one or two that are actually already in operation.
Yeah, that's interesting. I think Alan was going to ask you a question about a motor.
Yeah, sorry
Okay.
to digress a little bit. You said a 4-cylinder motorcycle. Have you researched that to find something that is preferable?
So a lot of your sports bikes, back in the late '90s to early 2000s, they all started going to nickel engines. So they're almost all of your sports bikes are aluminum blocks with aluminum pistons, and they're carbon or ceramic with nickel silver lined cylinders that have been honed, similar to the Geostorm engine that I talked about, where
Right.
you have an aluminum to aluminum contact with the exception of the carbon or silicone that's on there for friction reduction.
Yeah.
Um,
So like an
so a lot of
early
motorcycle
CBR.
engines are built like that now because they're so high revving. They have to have
Yeah.
all different kinds of engineering in them for
Yeah.
friction reduction.
Got it.
Yeah. So I actually owned Yamaha SP6R,
Mm-hmm.
which is it's an inline four, and I did the research on that engine. When I found out what kind of engine was in it, that's immediately when I knew what I wanted to do next, what kind of engine I wanted to go with.
Okay, makes sense. Thank you.
Yeah, good. Well, do y'all have any other questions? Is there anything?
Oh, I've got this needs to go on for days. I was a little intrigued before. I'm way intrigued now.
Yeah,
It's not so all the different things that were in the system, the individual components of them are readily available to research online, and there's probably a ton of videos on YouTube for the individual components. But when I was researching it and I was looking for somebody that had done the entire system the way that I wanted to do it, I was unfortunately not able to find anybody that posted anything from start to finish of building a solar concentrator with a steam powered engine generating power to run a house. So one of the things that me and my wife have talked about when we go out and we find this land is we are likely going to be doing a YouTube channel to show the whole process, not just the power part of the house, but also building the house. So obviously it'll take some time to do it, but we plan on posting our progress and what we're doing for the whole thing out there.
That would be awesome.
Sweet.
yeah. And have you considered writing a book?
With all your free time.
Yes.
I don't have the patience or the attention span to do that, to be honest.
Yeah.
I mean, maybe if I can dictate to my phone and my phone does all the typing.
Maybe.
Yeah.
Uh-huh.
Yeah, but I mean, as much as I appreciate the person that likes to sit down and read a book, I don't have the attention span to do that. I can read tons and tons of technical information online until I fall asleep, but the medium that most people are learning from now online is actually video.
Yeah. You're right about
That's why
that.
YouTube is so successful, is because it has moved so much of the learning platform of absorbing information to a much faster medium of watching a video of something. You know, somebody wants to learn how to rebuild their transmission for almost any model of vehicle out there, they go to YouTube and watch a video. And they consume the information that somebody went to school for over the course of a year to learn how to do.
Yeah.
So it's become the point where people like us, you guys, you know, with your podcast and when I share information or whoever, it's become we're all teachers. So
Yeah.
really, it's an awesome method for people to move forward and do what they want to do more easily.
Yeah. Well, it is incredible.
One question I had for you, Pete, is we didn't really talk about it in detail, but I'm assuming that you were running at least 120 volt current.
I was running 220.
You were running 220.
240 to the house. Yeah, I was
So-
running two phases of.
If somebody was wanting to build a conversion, like they have a traditional home that's on the grid, and they're wanting to convert over to this system, would the system that you've described would it generate enough to run an AC unit in Texas?
With battery backup, so with the size dish that I had and the power that I was producing, it would run my air conditioning system, but barely, because my air conditioning system in this house is not the most efficient in the world, to be honest.
Right.
So with battery backup, it would do it no problem as long as your inverter was big enough.
Okay.
But here's the issue. If you're talking about somebody that wanted to go completely solar power, take their house off the grid and do it that way, then yeah, you can build any size system that you want. You could have two of those C-band dishes side by side, and you could generate 15 kilowatts of power if you wanted to.
Okay.
But if you ever wanted to go grid tie, there is no power company that I know of in the United States that would look at your system and say, yeah, we'll go ahead and allow you to tie that to our grid.
Right.
Because it's a homemade system
Right.
and there's nothing UL listed about it, they will say no. So you are specifically talking about someone that wants to go off grid with this kind of system. Until they have mass production solar concentration systems that are available commercially and they're UL listed and backed up by certification and all that stuff, there's no power company that would actually say, yeah, we have no problem with tying that to our grid, because that puts their grid at a higher risk. If I have any kind of component failure on my side that shorts the grid,
Yeah.
then they have potentially hundreds of customers that go down and possibly popping transformers and stuff like that, and they just
Sure.
don't want to deal with that. That's why everything that they tie to, they almost always require it to be UL listed and certified.
Okay, so let me throw another thing at you. So as an experimental project to learn more about this, I have a barn that's remote from my house, and it's not hooked up to any electricity, and I'm wanting to move my fabrication shop out there, and then I'm talking the biggest piece of equipment would be just an arc welder, okay, and I'm wondering if I could build a system to power that as an experiment to learn from and yet be successful.
So, with my dish and my generator coil, at peak power in the day, I was generating 7.6 to 7.8 kilowatts of power. So, 7,600 watts to 7,800 watts. Any piece of electrical equipment, I don't know what your background in engineering is, but
Not electrical.
Mechanical. Mine's mechanical and kind of electrical.
Okay.
Simplest method is amps times volts equals watts. So, like my Lincoln arc welder that I have, I think at max power it draws 21 amps at 240 volts.
Right.
So if you take that 240 times 21 amps, that gives you the wattage that it requires to run. So if whatever you're using to generate power, or a combination of power generation and battery backup is capable of supporting that wattage, then yes, you can.
Okay. Interesting.
Yep.
Yeah.
Anything that is UL listed, any electrical device is required to have two of the three pieces of information on it to be sold in the United States. It has to have either wattage, voltage, or amperage. It has to have two of those in order to be certified and sold in the United States. So you can figure out what your power requirement is for that device to run it.
Okay. That's good information.
But,
Oh, it's all been good
and
information.
if anybody wanted to look that up and research it, it's primarily called Ohm's law,
Yeah.
but
Yeah.
for power consumption purposes, your power is your wattage equals amps times volts. So as long as you have two of those three, you can figure out what the third is. If you have watts and volts, you can figure out amps. If you have amps and volts, you can figure out watts, and so on and so forth.
Cool.
Okay. Yeah,
Very
that makes
good.
sense. That was simple. All right. Well, I think unless there's another question, or I would like to have you on maybe another day if you're willing and talk more about the berm house. That's kind of fascinating to know what you know, or we can go ahead and talk about that here. But I think one of us has to leave in a minute. So.
Yeah, I probably need to get going too. I got some work to do on the house.
Yeah. Okay.
Perfect.
Well-
Very interesting. Super glad to meet you and have this discussion today.
Awesome. Thanks for the opportunity, and I hope I help people out with whatever they're pursuing for alternate power methods.
Absolutely, and I think it would be awesome, as Matt said. Maybe we can keep up with your progress as you build your home and go through all of that. You know, we'd like to possibly be a part of learning through you what you figure out.
Cool deal.
Okay. All right. Well, good luck with whatever you're working on today, and I appreciate your time today, Pete. Once again, we appreciate you taking time to tune in to Sabbath Lounge or Shabbat Lounge. And Jake, any last words?
Nope. That's all I got.
All right. Sounds good. Thank you for listening, and we'll catch you next time.